So this is one of the trickier integration by substitution examples. So we'll have a go at E. Right, so let's go through our checklist. So we've got an integral in terms of x, with limits in terms of x, and a substitution u equal to the square root of x. So u is the square root of x as a substitution given. First thing we want to do is find du by dx. Okay, well, let's rewrite this as x to the power of half. That'll make it easier. So du by dx is 1/2 x to the power of minus a half. Again, let's rewrite that. That'll be 1 over 2 times the square root of x. Okay, that's du by dx. We want to have du, we'll replace it. So du is equal to dx times both sides, so that's going to be dx over 2 times the square root of x. Now we have to write x in terms of u. U is the square root of x, so x is u squared. So now we have both components. Let's go back to our original integral, which was from 4 to 1 dx over the square root of x times 4x minus 1. Let's have a look. So I've got du is dx over 2 lots the square root of x. And I've got dx over the square root of x. Well, that's a whole, not a half. So that means that 2 du is equal to dx over the square root of x. So this is going to become 2 du. Now I've got to my bracket, so I've got 1 over 4x minus 1. X is a u squared, so we'll make that 4 squared minus 1. So let's write that as 2 du divided by 4u squared minus 1. Okay, so there's our integral. Right, now, remember we said that if I have an integral of something multiplied or divided, that was hard. If I have something where I have an integral of something added or subtracted, that was better. That's what we're trying to get to. So now the problem is here I've got this. So I've got 2 divided by 4u squared minus 1. So using our mathematical knowledge, we can split 2 over 4u squared minus 1 into 2 over 2u minus 1, 2u plus 1 du. Okay, so now I've used dots to separate that into 2 parts. Now, why do we do that? Because now what we can do is we can treat these as, we can split them into partial fractions. Remember doing this? If not, have another go. 2u minus 1 minus 1 over 2u plus 1 du. So now I've got something plus or minus. That's going to be easier to integrate. One thing I have to do before I do my integration, we had limits in terms of x. So when x equals 4, u is equal to the square root of x, u will be 2. When x is equal to 1, u is the square root of x, so u is 1. So my limits are 2 and 1. So now all I have to do is work out what this is. So I've got 1 over 2u minus 1. Well, okay, so we know that's going to be log normal of 2u minus 1. But remember the chain rule. Okay, so I'm going to have to take that a that's multiplying u and divide by that. So I get a half. Minus log normal of 2u plus 1. Again, I've got an a, so I divide by that, so I've got half. And I put my new limits in terms of u. Okay, so let's put I said before, this is a really good way to do this, so you don't get any sign errors. You're picking up method marks. So let's evaluate the first bracket for 2. So I've got a half log normal of 2 times 2, which is 4, take away 1, 3. And then I'm taking away from that a half log normal 2 times 2 plus 1, which is 5. Second one, we evaluate for u equal 1. So I've got half log normal 2 times 1 minus 1, which is 1. I'm subtracting from that 1 half log normal 2 times 1 plus 1, which is 3. Now that is equal to, well, the first thing I notice is this is the log normal of 1, which we should hopefully all know is 0. So we can ignore that term. So what I've got is, I have got a half log normal of 3, take away a half log normal of 5, plus, because we've got negative and negative, plus a half log normal of 3. So I've got a whole log normal of 3, and then I'm taking away a half log normal of 5. Right now, law of logs. I can't combine these two because this has got a different coefficient. What I can do is, instead of writing a log normal of 3, I can write this as the log normal of 9 to the power of a half minus a half log normal of 5. So we all know what we can do with that. I can write that, I can take that power to the front and write the square root of 9 as my log. So now I've got a half log normal of 9 minus a half log normal of 5. Okay. So now I've got that, I can basically combine my two logs. So that's going to give me 1 half log normal of 9 over 5, and we have solved the problem.